Hello, this is Mr. Joseph. I just wanted to go over this and try to clarify some things from class. So the first instruction says to measure the sides. So if we see, I just gave these some random numbers because I did not have a ruler, but I was trying to be reasonable. So FE is 6 millimeters, FG is 7 millimeters, and GE is 4 millimeters. So finding out finding out the sides are actually not too difficult. So for instance, if I said I had a scale factor of 2, then you know that our new shape, F prime E, will be 12 millimeters. FG would be 14 millimeters, and that G prime E would be 8 millimeters. Sorry, that should have been G prime. And that's if a scale factor of 2. Let's try a scale factor of 0.5. F prime E would be half of 6, so that would be 3. FG would be 3.5. And G prime E would be 2. So I want us to try to build some confidence here and just understanding that if we were to name how long the sides were, or label how long the sides were, that we are able to do this. Like this idea of scale factor of 2 means, okay, we're doubling it. The scale factor of 0.5 means we're taking half of it. So I hope that part is not confusing, because I feel like that is something that we all have access to. The difficult part is understanding how does this C have anything to do with what we're doing. So that is where I'm going to try to explain. So just keep in mind that a scale factor of 2, these were the measurements, so keep these in your notes, and a scale factor of 0.5, these were your measurements. Keep these in your notes. So what I'm going to do now is I'm going to erase all this. Let's see if I can actually make a big eraser, which is whole. So I'm going to erase all that. And I'll leave those measurements because we know those are the triangles. And I'm going to tell you how this center interacts with what we're doing. So I told you in class, if you're feeling you weren't sure how you're doing, to use a scale factor of 3 or 2. So we're going to just use 2 because we already knew the answer to that. So all you have to do is you pick the center and you go to each vertex. You just have to remember that this triangle is based on the center. We created this triangle based on the center. And if you measured the red, this would be 4, 4, and the red could also be 6. So when we want to create our triangle that is a scaled factor of 2, so we want our triangle to be twice as big and also based on this center that is given to us. So that means that from C to F is 4, and we already said that if we want to double the distance from C to F, we would just go 4 more, and that's going to give us F prime. Because we know that CF is 4, so C prime F is 8. So this is just saying how far away the center is from our new vertex, which is different than the sides, right? These are just the sides of the triangle, so you just have to separate those in your head. Next thing we can look at is we can look at CG, which is a distance of 6, and CG prime will be a distance of 12. So once again, I'm going to go from C to G, which is 6, and I'm just going to extend it 6 more. And this is where my new point is, G prime. And the last one is CE, which is 4, and CE prime needs to be 8. So I know I need to also go over 4, and this will be E prime. So these points are our new vertices of our new triangle. So now I'm going to connect. Okay, so we got that, this, and this. I know it's probably a little confusing because of different colors, but I'm going to erase all the distractions. And let me make sure to make my circle smaller because I know that will have an effect. Okay, so here we are. This is our new triangle. And sorry, this right here was 6 millimeters, right? So this right here is not only a triangle that is twice as big as the black, but it's also dilated through the middle. So if you did have a ruler and you measured from F prime to E prime, this should be 12 millimeters. And that was our goal anyways. Our goal was to make it twice as big. So if you did measure it, hopefully that you would see that it's 12. So when we did this process, not only are we going to get the right answers, so F prime G is 14, and G prime, I don't know what kind of G that is. G prime E will be 8. Not only will these measurements fit that, this would be 14, this would be 8, and from here to here would be 12. But we can also say that it's dilated through the center because when I make a line through the points, they will always connect perfectly, or they should connect perfectly. And that's what we mean by dilating through the center. So I hope that helps. And now we're going to do the same process, but this time we are going to go smaller. And I'm going to do a quick run through of that since we're going to also do that in class. Okay, so once again, I'm going to start by going from the center to each vertex. And I've already told you this was 4, 4, 6. So if our scale factor is 0.5, that means that from C to F, right? I'm going from C to F. That is considered a scale factor of 1. But if I want a scale factor of 0.5, that means my F is going to be in between. So this would be F prime. From C to E, if it's 4, going from C to E, E would have to be in between. Probably use a different color. And then from C to F, I want to be halfway, which is probably right there. And my new triangle will be right there. And if I get my eraser and I am really careful, I should be able to take out all the purple. And the cool thing about this is an app called Notability. And I'm using an Apple. You can really just get the details out. And I'll connect everything back with the red. Once again, not perfect, right? But it will do. And I hope that you see that this triangle is half as big as our original. And once again, if I matched up the vertices, they will line up perfectly. And I think I did a better job on this one because you can see that it kind of lines up easily. So I hope that helps. Shoot me any questions if you need anything.